Dear students, greetings of the day. Welcome you all to the course that is Fabric Manufacturing Technology. So in the last sessions we have discussed about particularly air jet weaving technology and as well as water jet weaving technology. So we have discussed about the air jet weaving machines. What are the different types of air jet weaving machines are there? What is the complete weft insertion process and phases of air jet weft insertion, and what are the different types of nozzles we are using in the air jet weaving machines, and what are their functions, and what are the different settings in the air jet weaving machine we have discussed in the last session. And along with that we have discussed about the water jet weaving technologies. So what is exactly the water jet weft insertion, and what is exactly the picking mechanism which we are using in the water jet weaving machines, okay, and what are the different elements which are involved in the weft insertion process, loom settings, and what are the features of water jet looms we have discussed. So today we will discuss about the multiphase weaving technology. So all about we are discussing shuttleless weaving machines. Okay. So the shuttleless weaving machines basically we have classified into 6 categories. Majorly where there are 4 different types of shuttleless weaving machines. As we have discussed about the projectile weaving machines, and we know that what is exactly the single projectile weaving machine and multiple projectile weaving machines are. And the next shuttleless weaving machine we have discussed about the rapier weaving machines. So in the rapier weaving machines we have discussed about what are the different types of rapiers and how these rapiers are classified according to the number of rapiers we are using, rigidity of the rapiers, and in terms of weft transfer, okay, how the 2 rapiers are transferring the weft yarn. So we have classified all the rapier weaving machines. So then coming to the third aspect, that is called as the fluid jets, we have discussed. So the fluid jets category we have discussed air jet and water jet. So we have discussed about the air jet and water jet weaving machines. So till now, along with these shuttleless weaving machines, we have one more shuttleless weaving machine, that is multiphase weaving machines. Okay, and we have a circular weaving technology. Okay, so these 2 we will discuss one by one. So today's session we are going to discuss about the multiphase weaving machines. Okay, so what is exactly the multiphase weaving technology? Okay, so how this weft insertion and what it is different than the other shuttleless weaving machines. Okay, what is the term it is multi-phase weaving machines? So now we will discuss one by one. Okay, so let us start about the multiphase weaving technology. So the Sulzer textile innovation, this is one of the major innovation. Okay, so there are different types of multiphase weaving machines. Out of these, the M8300 is the most popular multiphase weaving technology. So what is how it is going to be work is one of the major thing. So these multiphase weaving machine, or the working of multiphase weaving machine, is different than the other shuttleless looms. So name itself you can say that the multiphase. Okay, so generally in case of shuttle looms or shuttleless looms, so till the shuttleless looms like rapier, projectile, and the air jet and water jet, so the weaving is going to be occurred. So the interlacement of warp and weft is going to be occurred peak by peak. So that is nothing but, so at a time we are going to produce one shed, okay, and opened shed. In the opened shed we are going to insert the Weftian, that is picking then can be done. Then after that the beat up is going to be occur. So it is simply like at a time we are producing only one shed, only we are inserting only one weft thread in the opened shed. Okay, but so these whatever the multi-phase weaving machines are there, multi-phase. So multiple sheds are going to be opened. So in case of M8300, we are going to open simultaneously 4 sheds. Okay, we are opening simultaneously 4 sheds at a time. Okay, and in the 4 sheds, so simultaneously 4 weft threads will be inserted, or picks will be inserted, and these 4 inserted weftians are going to be beaten up or so with the help of beat up elements. Okay, so this is the basic difference between the normal shuttle looms and shuttleless looms compared to the multiphase looms. So you have to remember that. So at a time we are opening 4 different sheds. We are forming 4 different sheds simultaneously. At a time we are forming 4 sheds. 4 pick insertion will be done simultaneously at a time. So 4 beat ups will be occurred. So if you compare with this one, the production rate of multiphase is, I can say, 4 times more. 4 times more. Okay. So now, in case of multiphase weaving machines, what is the picking mechanism? What is the beat up mechanism? What are the elements which are involved in the woven fabric manufacturing process? One by one we will discuss. Okay. So that is the basic difference. And now the 3 priorities these revolutionary developments were performance potential, one thing, and ecology and economy. These 3 priorities are taken into the consideration and they have developed the multiphase weaving technology. Even at the market launch, its performance was 3 to 4 times that of the modern edge-jet weaving machines. So the performance nothing but I can say the production rate, that is the production of the multiphase weaving machines are 3 to 4 times greater than that of edge-jet weaving machines, because here also we are using an edge-jet nozzle to insert the weftian into the weaving elements already opened sheds. Okay, so that is the thing. Now the performance of this M8300 is far superior to other weaving machines. Okay, the M8300 produces simple standard fabrics with extremely high weft insertion rates. So you can remember that, you can understand here simple standard fabrics nothing but, so the fabric structures concern, so the basic fabric structures are possible in case of multiphase weaving machines. Okay, so once again I am repeating, the basic weaves or basic fabric structures are possible in case of M8300. That is like you can say that the plain weave, twill weaves, and sometimes it is a satin weaves also. Okay, so the simple standard weaves are possible in case of the multiphase weaving technology with high weft insertion rates. High weft insertion rates, that is high picks per minute. Okay, now simple emphasis has been placed on producing the fabrics with these machines that meet the high quality of the fabrics today. Okay, so we are producing the fabrics with good quality even by considering all the factors. Then this has been convincingly achieved by the elimination of insertion faults and creating the basic requirements for the uniform fabric appearance. So the quality, in terms of the quality also, we can say that it is good. Okay, and the machine is having some additional attachments or additional features to identify the short peaks or the broken peaks in the shed. Okay, so that the fabric quality can be maintained, okay, as per the customer requirements. That is nothing but the quality can be maintained. Okay, so the Sullivan Textiles M8300 is the result of a development strategy focused on performance, potential, ecology and economy. Okay, as I discussed. So even in the development stage, the multiphase weaving machines already surpassed by for the performance of any other contemporary air-jet weaving machines. Okay, so you can see here the Weft is inserted continuously without interruption at an even pull of speeds of 20 to 25 meters per second. 20 to 25 meters per second. The stress on the yarn is significantly reduced. The stress on the yarn is significantly reduced in these multiphase weaving machines. So stress on the yarns nothing but in case of warp we are talking. So in case of warp we are talking. So the warp stress is very low as compared with the other shetty looms as well as the shettyless looms. Okay. So how this is going to be there like that we will discuss in the further slides. Okay. So coming to the multiphase weaving machines. So what is happening is, so we have the warp ends. You can see that the warp ends pass over the rotating weaving rotor. So we have a rotor. Okay. So on the rotor, the sheds are formed. Okay. So consecutively on its circumference by shed forming elements. So nothing but there is a rotor. On the rotor we have a shed forming elements. On the rotor we have a shed forming elements. So due to these shed forming elements, so throughout the circumference the shed forming elements and weaving elements are there. So with the help of the shed forming elements, the shed is going to be formed. So that is the thing it is explaining. So there is a rotor. So on the rotor we have a shed forming elements. Due to the shed forming elements, the warp sheet or warp shed is forming. Okay. So the motion of the rotor causes the shed forming elements to open the shed one after another. The Weft yarn is inserted by low pressure compressed air through the channel across the full width of the. So you can observe here the Weft yarn how it is inserting with the help of compressed air. So that is nothing but air jet we are using. So here also we are using air jet nozzles. Okay, air jet nozzles. So the low pressure compressed air through the channel across the full width of the fabric. So with the help of compressed air, we are inserting the Weft yarn into the opened shed. Okay. So shed is forming with the help of shed forming elements on the rotor. Now after shed formation, we are inserting the Weft yarn with the help of compressed air. Okay. Now it is called as the shedding. So the shedding operation is completed. Now here the Weft insertion is occurred, that is picking has been done. Okay. Now the 4 picks can be inserted simultaneously. Okay, because in the shed forming elements, so whatever the shed forming elements we are talking, so there are 12 sets of shed forming elements and 12 set of nothing but 12 set of shed forming and weaving elements on the circumference of the turn or rotor. Okay. So now out of 12 shed forming elements, 4 sheds are going to be formed at a time, so that the 4 Weftians can be inserted in simultaneously. Okay, so we will see diagrammatic representation. The Weftian insertion will be done. So total 4 sheds will be formed. So the 4 picks are going to be inserted in the 4 sheds simultaneously. Okay. Now the yarn velocity 20 meters per second at an insertion rate of 5000 meters per minute. 5000 meters per minute. Okay. So you can calculate that if the for example, if you have the fabric width of 2 meters, for example. So if the fabric width is 2 meters, so fabric width 2 meters, nothing but what is the weft insertion rate? Insertion rate of 5000 meters per minute. 5000 meters total, 5000 meters. And what is the fabric width I told? I have told that is 2 meters. So 5000 divided by 2, that is equal to 5000 divided by 2, that is equal to 2500. So this is 2500 picks per minute, ppm. So simple. If you want to calculate this weft insertion rate in meters per minute to picks per minute, then what you have to do? You have to know that what is the fabric width and total weft insertion rate in meters per minute divided by what are the meters. So you can do that the calculation. So you can calculate that what is the weft insertion rate in picks per minute. Okay. So approximately, so if you compare with the normal air jet weaving looms, so as I told that 1200 is the weft insertion rate. So now if you compare with this is 2500, it is as low. Okay, so 2500 picks per minute. In that case, air jet, normal air jet, so it is approximately 1200. Now it is doubled, more than doubled. So 3 to 4 times, that is why I told that the production rate as compared with the air jet looms, so 2 to 3 times, or sometimes it is more than the 3 times also be there in case of multiphase weaving machines. Okay, so the beat up will be occurred. Now up to this, what is completed? The picking is completed. Okay, so after picking, there are beat up combs. There are beat up combs, that is nothing but beat up elements. So there are simple elements which are going to beat the newly inserted weft yarn to the fill of the cloth. So you can see here. So the beat up combs are located on the weaving rotor between the rows of shed forming elements. Okay. So as I told, there is a rotor, shed forming element, one beat up element, shed forming element, beating element, shed forming element, beating element, shed forming element, beating element. Like that, we have 12 sets. Okay. So we have 12 sets of shed forming elements and beat up elements. So every shed forming element is follow the beat up element. So after shed opening, picking will be done. After picking, this beat up element is going to beat the weft yarn towards the fill of the cloth simply. Okay. So that is, it is mentioning. So you can say that the shedding, okay, and picking, and here the beat up, all primary motions are over. Okay. So after that the cloth fill and the warplet of secondary motions are over. And the auxiliary motions, as we have discussed, so there are warp stop motions, weft stop motions, okay, brakes, so everything is there. Okay, so this is the related to the introduction to the multiphase weaving machine. Now we will see what is exactly the rotor, what are the shed forming elements, what are the beat up elements are. Okay, so coming to the diagram, you can see here, so this is called our rotor. So generally we can call it is a weaving rotor because the interlacement is going to be occur on the weaving rotor drum. Okay, so you can see here. So this one is called as shed forming element. Shed forming element, and this is called as your beat up element. So as I told, one shed forming element, one beat up element, one shed forming element, beat up element, shed forming element, beat up element. Throughout the circumference of the rotor, we have total, I am telling, total 12 shed forming elements and beat up elements are present. Okay, so now you can see here what is going to be happen in the how the shed formation can be occur and how the beat up is going to be occur. Now what is the direction of rotation? So which side is the face side, which side is the back side, front side and back side. So you can see you have to identify that the cloth fell. Where is the cloth fell? So you can see here, this is your cloth fell or fell of the cloth, and your warp is coming here. So these are the warp threads, or you can say that the warp sheet. Okay, now here you can see that the fourth one, that is called as warp positioners. Warp positioners. Warp positioners. So with the help of these warp positioners only, the warp yarn has to be formed top shed or bottom shed is going to be decided. Okay, so these are very important. So here you have to observe how the shed formation is happening with the help of shed forming elements. But if you observe in the other cases, shed formation is occurring in the air jet, normal air jet, water jet, rapier, projectile, and even in the shuttle looms also, with the help of heeled frames. There are heeled frames in the particular case. Now here there is no heeled frames. Now here there is no heeled frames. Now we are not using any kind of heeled frames, but how the yarns are going to be divided into two sheets with the help of shed forming elements, and whether the yarn is to be formed top shed or bottom shed will be decided by the warp positioners, so that the upper shed and lower shed will be going to occur. So you can see here, so this is called as the upper shed. So upper shed, and this is called as the lower shed. Okay, this is called as the lower shed. Okay, so upper shed and lower shed. Now you can see here, so shed forming element, say this is 1, 2, 3 and 4. Now you can observe that Weft yarn, this is the Weft yarn. Okay, Weft yarn 1, Weft yarn 2, Weft yarn 3, and this is the fourth one. Okay, so as I told earlier, 4 sheds at a time we are forming in the multiphase weaving machines. Okay, so 4 sheds, 4 Weft yarns are going to be inserted. Now what is happening is, so the warp sheet, so like these elements which are there throughout the width of the drum. So this is the width of the drum. Okay, so these are the shed forming elements and these are the beat up elements. Okay, so shed forming elements and beat up elements, there are n number of shed forming elements and beat up elements. So it is simply, so if you want to produce a plain fabric or plain weave, so the warp ends or warp sheet is having 5000 number of ends. So on the rotor, minimum in one row, minimum 2500 shed forming elements should be there. Okay, simple. So half of the warp threads which are available in the warp sheet to be there in each and every row. Okay, so then only it is going to be possible to form the top shed and the bottom shed, otherwise it is not. Okay. Now you can observe here, so this yarn, particularly you observe this yarn. Now this yarn is not folded on the, say, the shed forming elements are like projected outside the surface of the rotor surface. For example, if the warp thread is fall down on the top of this shed forming elements, so the warp thread will form the top shed. If this warp thread is fall down on the beside of the shed forming elements, so now what is happening? So the lower shed is going to be formed. So the particularly I am repeating here, if the warp thread is fall down on the top of shed forming element which is going to create top shed, and if the warp thread is falling down in between the shed forming elements, it is dropped down, then it is going to form bottom shed. Now you can observe here this warp thread which is not fall above on the top of the shed forming element, so it is slipped below, so it is forming the lower shed. And other end you can observe that this yarn is on the top side, so top shed is formed. And this yarn top, when here it is top shed, right? Now this yarn again it is going into the next phase, into the bottom side. Now this yarn is going to the top side. Okay, so again it is on the top and again it is on the bottom. Okay, you can see that this is one shed, this is second shed, this is the third shed, so it is forming like this. Okay, this is the fourth shed. So 4 sheds are formed. So after Weft insertion, what is going to happen? So this beat up elements, so the rotor is rotating like this towards the side of the fell of the cloth. So after Weft insertion, the Weft yarn which is inserted, newly inserted Weft yarn is going to be beaten up with the help of these beat up elements simply. Okay, so this is how these 4 sheds are going to form at simultaneously, and 4 Weft yarns are going to be inserted in the 4 sheds and the 4 beat up elements. So subsequent of these shed forming elements we have beat up elements. So these beat up elements are going to beat the Weft yarn towards the fell of the cloth. Okay, so this is how complete multi-phase weaving technology is going to be there. So this is how the fabric formation will occur in the multi-phase weaving. Now if you want to produce another design, so different design, so here if you observe the warp positioners 1, 2, 3, 4, 5, so depends upon the design requirement, so these positioners will going to move across the rotor. So it is going to move across the rotor. So whether it should be fall down on the top of the shed forming element or the below the shed forming element, so these warp positioners will decide. So according to the design, these warp positioners are going to move. Okay, so that is the major thing. And you can observe here the complete rotor, how this weaving rotor is. So here, so all the shed forming elements, like throughout the width of the rotor, all the shed forming elements are there, and throughout the width all the beat up elements are there. Now you can see these are the warp positioners. So where you can understand here particularly the warp threads are passed through the warp positioner. So you can observe here this place. So this thread is passed through this. Now this thread is passed through this. Now this thread passed through this. Okay. So now if it is changing the position, if it is horizontally moving, that is why you can observe that the arrow has indicated the warp positioners are going to move across the width of the rotor, across the weaving rotor. So that is the major thing. So now this is how the selection is going to be occurred. This is how the weaving is going to done in case of multi-phase weaving machines. Okay. So you can observe that this is the complete drum, and you can see that the warp positioners. So these are the warp positioners. Okay. And you can see that these warp threads, you can observe this thread is going down to form the lower shed, and this thread is gone on the above, fall down on the top of shed forming element to form the top shed. Now this yarn is fall down lower shed, this will be on top shed. So one by one. So now with the help of these beta elements after the weft insertion, you can understand here the dots are indicated 1, 2, 3 and 4 picks are there. So 4 positions, 4 sheds are formed, 4 picks are inserted. After the weft insertion, this beta element is going to beat the newly inserted yarn. This is the newly inserted yarn. So this beta elements is going to beat. After beating, this will be going below the fell of the cloth. Below the fell of the cloth. So there is no obstructions will be occurred with the help of because of these beta elements. Okay. So that are beta combs also. See, we can say that, and you can say that you can see here the particularly shed geometry. So these are the weft yarn, and this is how the shed forming element exactly looks. Okay, this is how the shed forming element exactly look. Now, why it should be there? This gap is there. The opening towards the beta elements. The opening is provided towards the beta elements because the drum is rotating like this. So what will happen when the drum is rotating after the weft insertion? So this weft yarn is going to be pushed out from the shed forming element to fill the fabric. So otherwise, if there is no slit in the shed forming element, how this weft yarn is going coming outside? Okay, so that is why it is provided towards the beta element. So you can understand that the rotation of the rotor. So you can observe that when it is rotating, this lower warp sheet is going to push up the newly inserted yarn to come out from the shed forming element, so that the weft yarn is now free. So the beta will be up. So this is how complete picture of the shed forming elements and beta elements in the multiphase weaving technology. So these are the elements. So complete elements. So as I told, total 12 positions. So you can observe that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 12 beta elements and 12 shed forming elements on the weaving rotor. Okay. So this is the complete picture of the you can see here. So this is the warp beam. The warp sheet is releasing from the warp beam. So there are selectors. Okay, and this is the weaving rotor. So after the fabric formation, the fabric is going to be taken up with the help of. So this is called as our take up mechanism. Then after that, the fabric is going to wind on to the cloth roller. So this is the cloth roller. These are the shed forming elements, and below this back side we have a warp beam. So here there is a rotor where the actual shed formation and the weft insertion will be occurred with the help of again with the help of air jet nozzles. So this is complete picture. Okay, and the weft insertion rates also you can observe that what is the velocity and what is the weft insertion cycle. Okay, rate, what is the speed actually. Okay, now this is how the warp beam, as I told, the back side of the machine. So the warp sheet is going, and at that side we have the shed forming elements and the beta elements, everything. That is weaving elements are present. So after woven, the fabric is going to wind on to the cloth roller. So this is the creel stand particularly for the weft yarn packages. Weft yarn packages. Creel stand for the weft yarn packages. Okay. So from this only the Weft yarn is going to taken up. So four yarns at a time we need to insert. So 4 minimum packages are required in the reel. Okay. So now you can observe that the warp sheet is coming with the help of the shed forming the warp positioners, as I told. So these are the warp positioners to position the warp yarn on the shed forming element or beside of the shed forming element will be decided by this. So after that, this is called as our rotor, complete rotor. Okay, and after that the fabric is going to wind up. So this is the loop, and these are the features. So the width of the machine is 190 centimeter. So this is 190 centimeter. Okay, so it is 190 centimeter. So these are the features or the model number or model details particularly. And you can see here there are 4 packages and 4 accumulators. So from the 4 accumulators, the 4 yarns are going to feed with the help of these, we can say the Weft yarn control system. We can say Weft controller. So Weft yarn will be going to pass through there are 2 discs. One is called as the standard disc and one is called as the rotating disc. So within that disc channels, the Weft yarn is going to insert it. And again, you have to observe that. So this is the fell of the cloth. So fell of cloth, fell cloth, or cloth fell. Okay. So as I can say that fell of the cloth, nothing but the first Weft insertion has to be done this one. Then you can see that the second yarn, second Weft thread and the third Weft thread. So as I told simultaneously, but there is a small changes in the timing because the rotor is rotating, right? So at a time if you insert also there is no use. So that is why what is happening is, so the first pick is going to start first, then some time, a very minute milliseconds of time. So the second pick will be started, then third pick. So it is simply like a staggered in positions it is going to start. So this is the simple comparison of energy requirements with comparatively to the other machines, that is particularly so the agent weaving machines, and you can say that these 3 are called as M8300 weaving machines. Okay, so it is reduced energy and material and relative consumption of materials, space as well as the energy. So if you think all 3 together, so compared to the agent weaving machines, multiphase weaving machines are reduced to 50%. So this is the thing. Okay. Now, despite of this expansion of the range of weaving styles, the M8300 is and remains a high performance machine for the production of high quality standard fabrics at minimum cost. Okay. So these are one of the advantage, and advantages of multiphase weaving machines make their full impact when warp densities remains altered. Okay, so prolonged period of time, and these are the few applications, like you can say that the printed ground fabric, bed linens and work apparels, so light denim styles, etc. can meanwhile be produced the densities of more than 100 ends per inch or 40 ends per centimeter with the weaves, as I told, like plain weave and the twill weaves, 2x1 twill. Okay, so basic weaves are going to be produced in case of multiphase weaving machines. Okay, so these are the things. So the new application for the M8300, it is going to be ranges of like NE's count, that is 8 to 40 NE, and European and American customers were using the cotton, polyester, viscose and the blends of these all raw materials also can be used. So in case of plain weave, as well as we are going to use or produce different twills, that is 3 and 4 end twills they are using. Okay. Now in addition to increasing the yarn density, the filament yarns can also be woven on the M8300. So hence it is weaving elements and the shed forming elements. So we can also use the filament yarns. Okay. So far only the textured yarns in a tire range of DTEX 50 to 330 DTEX is there. So generally the intermingling and textured yarns are preferable as a weft. Okay. And if you use as a warp also, we need to maintain the tension levels and all the things. Then we can able to use in the weaving machine. Okay. So M8300 is high performance machine, and the performance data gathered in the industrial practice of the corresponding importance. Okay. So these are the simple explanation. You can go through this. Okay. So we will see before ending the meeting, we will see that what is the actual working of the M8300. We will see a small video on this. Okay, so that you can practically see how these shed forming elements, how these beat up elements, how the Weft is inserting into the 4 different sheds simultaneously. We can see that. Okay, so that you can understand better. Okay.
Shedding is an important motion needed to form the fabric. Shedding involves separating ends from the warp beam into an upper and lower shed. The space between the upper and lower shed creates the path needed for weft insertion. After insertion, the shed closes and the weft is beat up into the fell of the cloth to form the fabric. The shedding motion begins with the warp ends being aligned properly with the shedding elements on the weft channel. The shed formation unit and warp positioners move the warp ends from side to side to position the ends properly with each shedding element. The ends may be positioned on top of the shedding element or to the side of the shedding element. Ends placed on top of the shedding elements create the upper shed. Ends placed to the side of the shedding elements form the lower shed. As the rotor turns, the shedding elements keep the shed open for insertion. At the end of insertion, the shed is closed by the movement of the shedding element away from the warp ends. The closing shed removes the inserted weft from the weft channel for beat up by the reed. For example, to form the proper shed for a 1x1 plain weave fabric, the warp positioners move alternating warp ends above and to the side of the shedding elements. As the rotor turns, the warp positioners shift the position of the warp ends for the next weft channel's shedding elements. Therefore, the first shed created will have a one end up and one end down repeat across the machine width, while the second shed formed will have a one end down and one end up repeat across the machine width. For more complicated weaves, the movement pattern of the plating device is equal to the weave repeat. The insertion unit distributes the weft ends into the weft channels of the rotor. The insertion unit takes weft from the static packages in the weft supply module and synchronizes the ends with the turning rotor. 4 ends are simultaneously inserted. Each end is staggered in position across the width of the rotor. Platform 1 feeds weft channels 1, 5, and 9. Platform 2 feeds weft channels 2, 6, and 10. Platform 3 feeds weft channels 3, 7, and 11. And Platform 4 feeds weft channels 4, 8, and 12. 2 main components of the insertion unit are the static disc and rotating disc. Both discs contain weft channels. There are 4 injector nozzles in the static disc and 12 weft nozzles in the rotating disc. As the rotor turns, weft is delivered into the corresponding weft channel of the rotor by air from the injector. When the end is clamped, the weft is fully inserted. However, delivery of the yarn continues. The injector nozzle creates a backflow of air through the weft nozzle. The continuous delivery of weft will create a loop in the channel during the time the end is clamped. As the rotor continues to turn, the end is cut. The tip of the cut weft is pulled back into the insertion unit channel system by the injector. The air from the injector guides the end into the next available weft nozzle. The weft insertion cycle now repeats.
So these are the references, and these are the references we have collected the information. Okay. So in the next session we will discuss about the circular weaving technology. So till then, thanks for listening. Bye.